If you dive 2.5 miles down into the Pacific Ocean, you leave the sun completely behind. At this depth, the pressure is crushing, and the water is absolutely pitch black. We are taught that the oxygen keeping us alive comes from a strict set of biological rules. Plants, trees, and sea algae take in sunlight, and through photosynthesis, they breathe out the oxygen we need. But scientists recently found something down in this freezing, lightless void that breaks those rules. Oxygen is actively bubbling up into the water, and there isn't a single drop of sunlight to trigger it. The source of this dark oxygen comes from strange, potato-shaped metallic lumps scattered across the seafloor. They are called polymetallic nodules. These unique formations sit quietly in the dark, generating oxygen completely on their own. And they were likely doing this billions of years ago, long before the first plant ever evolved to use the sun. But these stones have caught the attention of massive tech corporations. Right now, companies are drafting blueprints and prepping heavy industrial machinery to dive down and harvest them. We are finally discovering a hidden, independent source of life at the very bottom of our planet, right at the exact moment we've engineered the tools to strip it all away. These deep-sea rocks are densely packed with manganese, nickel, cobalt, and copper. Those are the exact elements required to manufacture advanced batteries. As consumer demand for new smartphones, laptops, and artificial intelligence data centers skyrockets, tech companies are desperately searching for new sources of these metals to feed their supply chains. To understand the scale of what they plan to do, imagine a massive tube dropping out of the sky right above your city, instantly sucking up cars, houses, and streetlights, completely leveling the neighborhood just to sift out a few metal parts. On the ocean floor, that process looks like giant surface tankers lowering heavy suction tubes thousands of feet into the water, violently scraping across miles of undisturbed sand. In the rush to build greener, battery-powered technology on the surface, we are preparing an apocalyptic extraction event for one of the most fragile, untouched ecosystems on Earth. The sheer mechanical force of dragging these underwater drills across the seabed creates a deafening roar that travels for miles, completely disabling the natural acoustic signals marine life relies on. Massive marine mammals, like blue whales, use complex echolocation to navigate the darkness, find food, and communicate. This wall of industrial noise effectively blinds and isolates them in the open ocean, and the noise is only the beginning. Once the pumps extract the metals on the ship, they dump millions of gallons of leftover dirt and sediment right back into the water column, creating underwater dust storms that stretch across the horizon. Deep-sea fish filter water through their gills. As this dense cloud of artificial sediment slowly settles back to the bottom, the suspended sand particles permanently clog those gills, suffocating local populations. The vacuums also blindly suck up ancient marine sponges that have sat peacefully in the dark for up to 11,000 years, along with fragile, transparent creatures called sea pigs that walk the seabed cleaning up debris. These bizarre, toxic little scavengers act as the foundational janitors of the abyss. If mining ships wipe them out, the biological waste they normally process will build up, risking an unpredictable and irreversible collapse of the entire oceanic food web. The great irony of tearing up the deep sea is that we don't actually need to do it to build our future. We already have the materials and the science to bypass the ocean floor entirely. Look in any landfill, and you will find millions of discarded laptops, old smartphones, and broken televisions. They are already packed with the exact metals we are trying to dredge from the sea. If companies redirected the millions of dollars spent designing deep-water drilling rigs into scaling up e-waste recycling facilities on an industrial scale, we could recover those resources without destroying a single habitat. Furthermore, the technology requiring these specific metals is already becoming obsolete. Major tech giants are currently shifting their supply lines away from lithium and cobalt, moving toward highly efficient sodium-ion batteries. These newer, cheaper, and longer-lasting batteries completely eliminate the need for rare metals. They rely on sodium, the exact same abundant element you find in ordinary kitchen table salt. We have all the alternatives sitting right in front of us. The only question left is what will happen to the ocean's hidden lungs and its ability to breathe in the dark if we willfully choose to lower the machines anyway.